We will continue now with lectures. Our next speaker is Milica Kovac. She is researcher and new business development manager at IC. She has a background in research psychology and 7+ years of experience in the market research industry, and she has made significant contributions to how we gather and interpret consumer insights. By actively investing efforts to leverage academic insights to drive practical applications, she brings a fresh perspective to the field of applied AI. Milica, you can start.
Thank you, Jelena. And thank you, everyone, for your interest in this field of market research. And of course, wholeheartedly thank you for our host for top-notch organization of this data science conference. So basically, this slot will be dedicated to the applied AI in the market research field with a special focus on eye tracking and predictive AI in eye tracking data, as it aims to be an exercise in the comparison between the two. So IC has started its journey 11 years ago as a Belgium-Serbian startup with the idea to break out with the traditional market research and everything that comes to your mind when you think about market research. Filling out long surveys, joining focus groups or interviews, and similar. We were inspired and remain inspired by the work of Kahneman and his distinction between System 1 and System 2 way of making decisions, and we actually ventured into developing technology that can help us better understand those System 1 decisions, or how we people, not only consumers, make decisions, which is fast, on an intuitive level, and vastly unconscious. And our journey led us to developing different technologies for that, including online eye tracking, but also online facial emotional coding, 3D virtual shopping, and a few others. But obviously, IC signals the first technology which we started developing, that is online eye tracking. And basically, that's a tool that helps us understand the eye movements through the integrated web camera of laptops and smartphones. In market research, this helps us answer questions like, what are the key areas of my website are seen? In what order? Are there any elements that are blocking the attention flow? Needless to say, the questions go beyond websites. You can ask pretty similar questions for other type of marketing materials, be it packaging of your favorite yogurt, or, I don't know, TikTok reel or TV commercial. Initially, we've started with classic machine learning algorithms for recognizing the movements of eye pupils. But throughout the time, we have evolved and integrated various algorithms that are measuring factors that come from participants, study participants, like their head size, head position, or the blinking, but also measuring factors that come from the environment. So the lighting, and we've incorporated face illumination, or the quality of the camera, so we integrated the video quality as well. The most recent algorithm we incorporated is the saliency one, which we'll speak about more later. Let's, for a minute, zoom out and understand the current dynamics between market research and AI. Whenever the crisis hits, we market researchers know that the first budget that businesses and marketing units will cut are market research budgets. And this is where AI comes into play, promising much better return on marketing research investments, much, much faster results for a more affordable price, and that are, as accurate as having human participants. And although I intend this slot to be AI optimistic, I do not want to completely ignore another important layer of AI in market research, and that is AI washing. Because this race for quick results really created perfect conditions for the proliferation of so many AI-powered solutions that everything is now AI-powered in market research. It doesn't come as a surprise that marketing is riding this wave of AI hype, but it really, I want to emphasize that here, it really makes it difficult to distinguish between what is really AI-powered and what is just AI washing. But speaking only about those genuinely AI-powered solutions, what we've heard yesterday and this morning, there are really numerous applications of both predictive and generative AI in market research. And I don't want to offer the systematization of all of them, but I do want to make an interesting and relevant distinction between AI solutions that are helping us market researchers with our processes, like data collection with synthetic AI respondents, or data analysis, reporting of results, making presentations, and all those processes in market research. And there's the other group of solutions that are genuinely AI-powered solutions that move the needle for market research by altering the possibilities of researching new topics or researching them in a completely new way. And this brings us to the predictive AI tracking, which is basically aiming to predict the visibility of key areas of, in the marketing content. So let's start with one case here in the video that I'm going to show you, which is a TV commercial for Kit Kat brand, Nestlé's Kit Kat brand. You will see in the upper half of the video the eye tracking heat maps. So the more red it is, more attention is given to that area, obviously. And in the bottom half of the video, you will see the predictions made by one predictive AI model. So let's watch it and try to compare them. Oh, we don't hear the sound, but that's okay. And I don't know why. I can't contain whatever's running inside. I gotta find a way to figure it out. I found the answers and there ain't no doubt. You got what I'm looking for.
Give me a break.
Got what I'm looking for.
So I believe I'm speaking on behalf of everyone when I say that this is really amazing. But I also do hope that you have noticed a few differences, not only the similarities. So the first one being related, for example, to brand visibility. If this was a research project commissioned by a brand, the first thing they would want to know is what is the outcome of this commercial to my brand. So whether the Nestle and Kit Kat brand was visible enough, how much attention was given to it, and what are the outcomes for the brand recall and other image attributes. So looking at these two, and knowing that Kit Kat is Nestle's brand here in Europe, but it's not Nestle's brand in the US, for example, a legitimate business question that might come from the brand is whether Nestle is connected to Kit Kat. Do consumers connect those two, and is Nestle's visible at all? So interpreting data from this AI model, we would say absolutely yes. Clearly, everyone will notice that Kit Kat is Nestle's brand. However, interpreting data from eye tracking would tell us that consumers are not interested in the manufacturer. They're interested to know that this is a Kit Kat brand, and that's enough for them. There were also two biases that are maybe not as relevant for this example, but they might be relevant for testing other type of marketing content, and it is worth noting those biases when we choose the adequate predictive AI model. If you remember from the closing scene when the slogan appeared, the heat map of predictive AI model was static the whole time, whereas the heat map of eye tracking was going from left to right, showing the people are reading. If we were to test a different sort of material, let's say an email marketing campaign, or a concept test, or a communication piece, where reading patterns are crucial to understand, we would need to choose a different predictive AI model than this one. And lastly, something I believe that this model hasn't been thought yet is that the most salient part of human face are not color contrasts or texture contrasts, but it comes from two places, either from the mouth or from the eyes. So if anyone was to roll their eyes at us, that would grab our full attention. This model didn't capture that. And knowing that, and I've mentioned the saliency, that is a very important construct here, because these AI predictive models are actually based on salience information. So Unlike eye trackers that are measuring the movements of the eyes, so the fixations, the saccades, the blinks, and everything, saliency models operate in a way that they extract the information for the stimuli itself, so the audio-visual information coming from the stimuli gazed at. And I'm coming across various predictive AI models on a monthly basis, and this whole landscape seems to resemble that AI washing I was telling you earlier on, which is why we were motivated to give this, do a little experiment and test this tech. Our experiment was inspired by a similar experiment that scientists from the Institute of Electrical Engineers performed last year. And what I've done is they've noticed that struggle that both academia and business have, and that is that results coming from eye tracking and predictive AI are often different, which is why they've chosen 18 different videos of different content and compare results between AI algorithms and eye trackers. This image here is taken from their original paper. It's not of the best quality, but I believe that you can distinguish that it shows two football players in red jerseys practicing with a ball. So they were comparing 3 different predictive AI algorithms with the eye tracker produced by Toby, which is a great one. And they've also asked some experts about their opinion on what will be seen in this scene. So we can see that the first algorithm picked up that the colored red jersey on on the white background will be the most significant point of this scene where people will look at, while other 2 algorithms were concentrating on players' faces. And just to be clear, both of these assumptions are justified from a cognitive science point of view, because we know from cognitive science that colors, especially red, in high contrast and human faces attract people's attention. But should I even ask what was actually that people were looking at here? Of course, the ball, because people understand the meaning behind this game. And we were really reflecting on this last piece of information and the statement about meaning beating the context-unaware saliency, and we were wondering how this translates to marketing, which is why we prepared our own experiment. We've chosen several stimuli that are typically tested in marketing studies, so be it packaging, web pages, virtual shelves, and so on. And we have compared 2 predictive AI algorithms that are available and quite popular on the market at the moment with the eye tracking data, which were coming from 2 eye trackers. The first one was the physical eye tracker Portable Lua. This eye tracker is produced by a Canadian company called DSC Research. They are making the best possible eye trackers in the world, which are actually produced for sophisticated academia research. And we have also deployed our own IC's remote eye tracking. So in order to simply compare between predictive AI algorithms and eye trackings, I'm going to share our 3 key insights on differences. The first one being that we've seen that predictive AI algorithms are consistently underestimating the significance of semantically important regions, in this example of brand name. So what actually this predictive AI algorithm failed to acknowledge here is that those letters are not just any letters of a specific font, size, color on some background. From marketing knowledge, we know that people are attaching so much meaning and associations and even emotions to brand names. What's more, different predictive AI algorithms tend to favor different properties. Some are biased towards textual information, some of them are biased towards image information or colors or contrasts. And here we could see that this predictive algorithm B was underestimating, I can use here, the importance or the visibility of this image, which is the central image of this particular packaging, for which we know that is the focal point of this packaging. A bonus insight that we have encountered in our experience with different predictive AI algorithms is that sometimes they're not trained on a specific stimuli type, which can undermine the insights for the whole category. And this is very relevant in market research because we work with different industries. We have clients from the FMCG, but also media, technology, banking, pharma, so you name it. And we know that there is no one algorithm that can work for all of this industry and that it needs to be leveraged, that industry-specific knowledge. However, I expect all of this to get much, much better over time, and this doesn't tell that AI predictive algorithms are bad. No, they're way more scalable than having eye tracker data with participants. And it's definitely possible to imagine a single application that would combine the salience information from predictive AI algorithms and correct it with a real-time feedback from consumer eye tracking data. That would also help to grasp more differences between different consumer groups, because currently these predictive AI algorithms are predicting how an average person would look at certain material. And my last 2 cents for this year's data science conference is that it is worthwhile including non-tech people into decisions of what will be fed into the algorithm in order to leverage that industry-specific knowledge. And also something that we are very bad at the moment in market research field, but I hope that will change over time, that is setting the standard in transparency about the AI model details, which can then guide the proper usage. So we need to be open into understanding what are the biases of every model. Thank you for your attention.
Thank you. So thank you for an interesting presentation. When you do this eye tracking, these heat maps, do you, so a person when looks at something, it's just a static average, or you look also at what the person looks at the first? So maybe it could be also important, what is the first thing I'm looking at it, not what is the area I'm looking at most of the time. Because in the football example, maybe the first thing is the ball, and the second thing is the foot of the second person which is washed because it's in the movement. So can you comment on that?
Yes, thank you for that question, and you're completely right. So with eye tracking data, we always look at, not just the average visibility in some time frame, but we can look at what was the first thing that was noticed, what is the order of fixations, and how that changes over time. I would ask that question in a slightly different way. I was more wondering about, for AI results, what is the time frame that is predicting for? So we don't have those informations, and those informations are the crucial ones, because for eye tracking data, we can know what was noticed at the first glance after 2 seconds, or what was noticed after browsing for 7 seconds. But with predictive AI models, we just have that one piece of information, and we don't know the time frame.
And also, when you do the eye tracking, you can test 1,000 people. And then it's every person has a different, maybe cultural background, and the AI model is only one result, which I don't know what's the basis of that actually.
Yes.
What is the basis? Is some training, or so it must be also based on some experiment, or?
Of course, yes. So with eye tracking data, we can test more people from different backgrounds and then find different patterns from, let's say, people from different geographies. But I do think that that's also possible with predictive AI models. If they're trained on people on AI tracking data coming from people from certain geographies. So I believe that there can be differentiation in predictive AI models, not having just one model that answers all questions, but having differentiated AI models that can also answer that question. That's it. Thank you.
Thank you. Thank you, Milica, for insightful talk and for nice presentation. We will have coffee break and be back here at 16:30.